Okay, so in this question we have a block of mass m moving with a velocity v down the slope at an angle alpha to the horizontal. We're given the coefficient of friction is mu, and we may assume that alpha is sufficiently large such that the block accelerates down the slope and does not topple. And we take gravitational field to be g. Okay, we need forces acting on the block. So let's look at this. Let's look at our options. So we've got the weight. This one acts downwards, so that's fine. We've got the normal reaction acting up, and we've got the frictional force acting that way. Are we missing any other forces? Doesn't look like it. So probably our answer is A. Let's check out the other options just in case. Now, in option B, we see that if this is wrong because the normal reaction should be perpendicular to the plane, so it should be there. So B is wrong. If we look at C, we see that since the block is moving down, the frictional force must oppose it, so this is wrong. The same thing can be said about the frictional force in this case. The frictional force must be acting upwards, so this is clearly wrong. And if we look at option E now, we can see that the normal reaction again is also wrong, and it's not in the direction that it should be. So this is wrong, and therefore the answer is A. Let's now move on to the next part. Okay, so in the next part of the question, we're asked to verify the following statements to state which one is correct. The forces balance when resolved horizontally. This is wrong because as the object moves down the plane, it's also moving horizontally. So this is clearly wrong. So A is wrong. The forces balance when resolved vertically. Well, as it moves down the plane, its height is also changing. So as it goes here, its height also changes. So B is wrong. The forces balance when resolved parallel to the slope. Well, it's moving in the direction parallel to the slope because it's moving down the slope. So this is wrong. The forces balance when resolved perpendicularly to the slope. Well, this one, let's think about it. As the block moves from this position that it is right now to this one, well, its position, the distance of the center of mass from the plate has not changed. Therefore, D is correct. And E is, so our answer is just D. Let's move on to the next part. So in this part, we are told V equals 0, T equals 0 as the equation for the velocity of the block as a function of time. So let's go ahead and try and find the acceleration of the block. So if we look at this diagram here, we can see that we can resolve the velocity of we can resolve the velocity of the weight of the block into two perpendicular directions. So this is 90 there, and we're going to resolve it into two components. So this angle here is going to be alpha, so this component here is mg, so this component parallel is mg sine of alpha, and the component perpendicular is mg cosine of alpha. Therefore, we know the normal reaction is equal to mg cosine of alpha, and the frictional force is mu mg cosine of alpha. Therefore, the acceleration A, the total resultant force down the plane, MA, is going to be equal to the downward force, which is mg sine of alpha, minus the frictional force, which is mu mg cosine of alpha. Therefore, the acceleration is g sine of alpha minus mu g cosine of alpha. Therefore, the velocity, which we can now use and plug into the equation v equals u plus at, because spot that this is just a constant acceleration. So therefore, the velocity is going to be just g sine alpha minus mu g cos alpha times t, because the initial velocity, as we given in the question, is 0. So our answer is going to be D, and this is our answer. Let's now move on to the next part of the question. Okay, so in the last part, we're told that there's now air resistance, and the resistance is given by this force here, kV. And we need to state what happens at t tends to infinity. Well, the situation is the same as a block falling under free fall, except now, instead of having the deceleration as g, we have our new g, as we said, equal to, from the previous part g sine alpha minus mu g cosine of alpha. So it's going to be the same thing. The object is going to reach terminal velocity, and we need to find the terminal velocity. So what is the terminal velocity is going to be? So it's going to be the same as when the total downward force equals to the opposing force. So it's going to be m times g sine alpha minus mu g cosine alpha, because remember, this is just the resultant force of the resultant acceleration of the body, this must be kv. Therefore, the terminal velocity is m into g sine of alpha minus mu g cosine of alpha, the whole thing divided by k. So therefore, if we look at our options, we see that these two do not make sense. Terminal velocity must be g sine alpha, mg sine alpha. So it's going to be sine alpha minus mu cosine alpha. Therefore, the answer is D. So we're done with this question.